Now, it's very important when it comes to transformers to consider safety. Safety with, firstly, we have to consider mounting. Okay, firstly, these transformers are huge, they are heavy, and as a result we can't just put them down. We need to put down a concrete slab which must be level, and then this transformer must be placed on top of that concrete slab. That slab must be able to withstand the weight of the transformer. Additionally, we have to mount safety signs. Safety signs needs to be mounted on this transformer and housing. These safety signs might include what PPE needs to be worn, that is not accessible to unauthorized persons, danger signs, and what to do in case of electric shock. Next, connecting. Okay, when connecting, always connect the secondary side first. Always ensure that the earth connections are done. So, secondary side first. Also ensure that earth connections are done. Okay, and as far as possible, ensure that when connecting the primary, that the power is off. Okay, when it comes to protection of transformers, we've got three types of protection. First one is electrical protection. Okay, electrical protection consists of fuses. Could have overcurrent protection. We can have earth fault protection, which uses the concept of a current transformer to compare the values in the phases and will disconnect the transformer if a fault occurs. We also have differential protection. Okay, differential protection uses relays to compare currents that's flowing through the transformer compared to the currents flowing out of the transformer, that is on a primary or the secondary side. If there's a mismatch of more than 15%, then the device will disconnect in time between 10 and 14 milliseconds. And then finally, electrical, we've got overexcitation, protection, which will activate if there's an increase in the voltage or a decrease in the frequency. Second type of protection that we work with is mechanical. The mechanical, we've got firstly the accumulated gas or the Buchholz relay. Okay, when we look at the transformer, it is mounted, the Buchholz relay only applies to oil-cooled transformers. Our transformer is placed inside our oil bath. This oil bath will have a pipe that connects to the Buchholz relay, which then in turn will connect to a reservoir. The reservoir will be filled with excess oil or sufficient oil, and because of the configuration that we've got, the inflow from the reservoir is lower than the outflow to the transformer. So what happens is, inside my Buchholz relay, inside the Buchholz relay, there's out and there's in. We will have a certain level of oil. We will have a flotation device placed in that oil, which then measures the amount of accumulated gas. So as this oil heats up, the oil degrades and it will release tiny little bubbles, which then accumulates inside the Buchholz relay. This will then in turn push the liquid level down, which will then push my flotation device down, and as it moves down, we will then have an alarm connected externally to this level to indicate when the excess gas has accumulated. The rate of the gas accumulation is dependent on the temperature of the oil. There is a little bleeder valve, a one-way valve, that when we open it, this little air pocket or gas pocket is allowed to escape through there, and we use that to ensure that no moisture enters the system to avoid the transformer from getting water damage. Finally, we've got the thermal protection. Thermal protection comes in three again. Firstly, we've got hotspot temperature, hotspot temperature protection. Okay, after years of studies, they found that a certain place in a transformer gets very hot when it is experiencing current. So what they do is they place a thermal sensor on this place, a little sensor that will allow an alarm or a tripping device to activate. Next, we've got heating due to overexcitation. Excitation. Okay, these are used in oil transformers, and the oil transformer basically will have a board-on tube connected to it. Okay, board-on tube is basically, we've got the connector here at the bottom that is going to connect to my oil tank. Then it'll have a pipe that is connected into a curve. There's a dial connected to this pipe, and as my pressure increases in this pipe, it'll cause this little pipe to want to extend, and as it extends, this dial is going to move, and that'll indicate the pressure that we have developed inside the transformer.